we've got a blue mat, like buy it, fix it. And we're on the blue mat today. These things are getting on my nerves. They can stay over there. Right, let's get rid of this. Let's try and be a little bit more organised. That can stay on there, don't need that. It's flipping cold in here. Right, so need to make some videos, run out of videos. I had a bit of a blitz about a month ago and backed up a load. Actually, it was less than that probably. Did some work on the motorhome before we went away in it and stuff, but basically I've got a whole load of stuff that needs fixing that's well past its sell-by date to get fixed. I have already started disassembling some of it. I think what I might do with this is, let's just show you what it is, what I've got. So it is a magnifying glass lamp. You might have seen one of these on the lockdown workshop videos, some of the original videos. I've got one of these Clark ones. They come from Machine Mart. Mine died but then came back to life again, I think, if you remember from the videos. This one's got a kind of not sure I want to do this, but let's turn it up that way. Take that off, bring it down here. Right, okay. So let's see if you can see what's going on. So no power at all. There is power to the switch, we think, actually. So let's just do some confirmation first. I think we're getting power to the switch. I haven't got a tester, so we're going to have to test the live and see that we've got 240 volts. Actually, this does come with a natty little gadget. So let's plug this in first and see what the crack is. So you can't see this. I've turned the telly I use for coaching round. Right, is that on or is that off? Right, that's on now. So I think I've got something on here that you can hold next to live, and it glows if it's no, that's the hold. So I thought there was something I could hold around here and it glowed if it was live. Well, that's weird, we're not getting no live up here. I could have sworn we checked the fuse. Let me try select and just make sure it's... Oh, I think you have to select it. Yeah, right, so I'm getting live feed there. I think there is a... I don't know what that one does. Right, so I'm reading hertz on there. A lot of hertz. Auto, not going to work on that. Right, I think what we can also do is we can see. I thought we could do some probing on that live thing. I don't know what that live does, to be honest. I don't use it for mains, but we've definitely got live coming in, so we know the plug's okay because I'm picking that up. Oops. EF. Right. So in theory. Right, so we're getting live to the circuit board from there. So that's live. That's not going to read live because that's neutral, but we're getting live. This is a decent gadget. Do you know it's only about 20 quid, this thing? You know, it's 100% Chinesium, but I've just measured it against a power supply and a couple of other voltmeters I've got, and it's something like 0.03 of a volt out at between 12 and 100 12 and 60 volts. I think I've got a 60 volt power supply. Anyway, so what I did notice, we will turn it off now. So we've established we've got mains. I haven't got anything like a dim bulb tester that I can test if there's a short, but I think I'm fairly confident this on the power supply. Now, what I need to be careful of is this is just been powered up, so what we need to do is just make sure there's no voltage on that. Right, that's interesting. Oh, there you go. So power is getting to that big mains capacitor there. So there was 180 something volts when I started on that then. We're down to 60, it's discharging, so it's obviously got something in the circle to discharge that. The probes themselves will be discharging that now, so that's going down nicely, down, 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 down. Usually with something like this, it's normally the capacitors that fail. So I did visual inspection on that capacitor. It doesn't look like it's blown, they tend to be bulged out on the top. So let's see if you can see that. I'll zoom down a bit now we've got out. The trouble is the lighting's not brilliant where it is at the moment. Oh, it's correcting itself. Right, so if I move that in, right, let's get my probe so I know I'm good. So that's the mains capacitor there that does most of the heavy lifting on the power supply. There's a proper name for it. I understand electronics, but I'm not an electrical expert. That's I think that's a smoothing transformer. That's the main transformer. So the power comes in here, it gets rectified, and then it goes out. And then there's a switching transformer there, and I think that's what that transistor does there. It's part of the switching. Now it's not rectified this, so it's not very smooth. What goes in there it's stepped down, and what comes out of here is then rectified after it comes out of here, is what I think, unless that there isn't a transistor, that's a rectifier, but I can't see. It just says Q1. So I would hazard a guess that's that. There's a big thermo resistor there possibly, or a resistor, but I think that's a thermo resistor. Reset resistor there. I think there's a fuse there, and I've tested that, and that's okay. I'm pretty sure that's a fuse. When I looked at it before, I'm trying to remember, it was a while ago since I did this. So if I put this onto continuity, what I should be able to test is there is continuity across that. Oh, that's weird. There's no continuity across that. Oh, it's not, it's a resistor. Let's just check it's not going the other way. That's fine. So it's a diode resistor, that. It's a one-way resistor. Now what I did find, I'll be honest, I was poking around in here, what I did find is no, that's weird. We're getting a reading on it now. Last time I checked this here, this diode here, I wasn't getting anything on it. I was just getting a short across it. So one way you should get resistance, and the other way you should get a short. Right, I'm getting resistance on both ways, which I shouldn't get. So I'm getting 0.6 kilo ohms, that's 600 ohms. And if I go the other way, you shouldn't get anything. I'm getting 0.6 ohms the other way. Now it could be that that's coming from something else. So I'm actually none the wiser now as to what's going on with this. Because I thought that had blown and I was just going to order another one of them, but it now turns out that it might not be. Let's just check that's discharged. Yeah, 1.3 volts. There's no voltage in there at all now. Right, so what I was going to do originally was just work my way through from the power supply through. Now for some reason I thought that was a fuse. It says it's a DAIN, whatever one of them is, a DAIN. Oh, that's the, I think that's the manufacturer. So I was hoping to take this out, but I'm not sure if I can get it. Ah! That's not coming out. can't see what it is. I thought I'd read somewhere on the board it said fuse, but... Or was it that one that was the fuse? Can't hold it under the microscope because I can't see it. Let me go and get another pair of glasses. Oh, 2 glasses. I don't know where I thought that was. So that says it's a T2 amp 240 volt, which kind of implies that that's a fuse. So it could be that's the fuse. 1 amp 240 volts. So that's the fuse. Right, that's the fuse. Right, that's good. We've got that. Not sure what that is. Somebody will be able to tell me what that is. So we're obviously getting power to that capacitor, so it is getting through there. Because if I follow the trace from the live comes in here, goes through that fuse. So that makes sense. Yeah, I will have checked that. That's the fuse. Then it goes through a couple of resistors. It hops across into that as well with the resistors on. I can't read what they are. They're in a bank anyway. Then it goes through the smoothing power supply. I think that's a smoother. There's I think that's a thermal cutout. Then it goes through what could be, I don't know what that is. I'll have to look that up. That's a small IC there. See if we can work out what it is. Right, so we've got 26 kilo ohms resistance there. Nothing there. 28 kilo ohms there. So we try that again. I might have to cut that bit off. Right, so let's try it again. We've checked voltage out on there. We're getting about 0.5 of a volt, but it is reading hertz, so that's No, we're not getting a hertz reading. So that's just it's that foobar it's reading. Yeah, give me a voltage reading. Right, so we've got 313 volts in on the transformer. Assuming this is the out. We will probe some other bits. It won't stay on. So hopefully that should hold now. No, I don't want it on auto. The only downside to this is when you put it onto volts, it keeps going back to auto. So we've got... No, I don't want 300 volts. Right, 300 volts there. Let's go back to resistance again. I'm going to go and get the other voltmeter out in a minute. That's interesting, 2.8 volts on that, out on that one. Oh, it's a different circuit, that's why. And that's not giving me anything. So I think it's these two that are the main outs. And it's not giving me voltage because it's not putting out any voltage. Yeah, when I get a connection, I'm getting about half a volt. That's probably a better one to go after. No, I'm not getting anything. And equally, I'm not getting anything across the output, so I think it's that little... Let's just turn this off. Turn it around my finger. It's It's that transistor there, I think that's died. So what we need to do is see if we can either get another one of them, or it's the bin for this. I mean, technically we should be able to inject some voltage into this, which we can probably do that now. So might as well desolder that. Let's turn this on. Don't need that. 300 and something should do. So just remember the one at the back. I have to put a bit of a blob of get 400. If not, we'll put a blob of solder on it and try and loosen it up. It's hot. There we go. We just need to disconnect that now. I haven't got a pair of decent pair of wire strippers in here, unfortunately. All my main tools are up at the other workshop. You don't resort to a pair of scissors. Well, it will either work or it won't if you get the wrong way around. Normally when it's got a line on, it's the positive one. Obviously I suspect there's a lot of Chinesium in this. Want to get it in there so I don't risk sticking the claws out. You can get yourself up there. Right. So if we crank the amps up a bit, we're not getting anything. Could be that it's the wrong way round. Nope. Right. Because LEDs are a diode, if I have connected these up the wrong way round. Aha! Weird, it's not giving me any amps. Right, so that's 12 volts. So we need a 12 volt power supply basically. So that's what we should be getting out there, and we're not getting nothing. So I am getting 1 amp draw. So I've just turned the amps down. It is drawing 15 watts, 1.24 amps at 12 volts. Let me fine adjust it down to bang on 12. Pretty much 12. Turning my amps down, there we go. Yeah, 1.24, it's exactly the same. So 1.25 amps, 12 volts, gives you 15 watts. And that looks about right. So the LED ring's actually fine on this. It is the power supply that's gone. So I'm putting money on it's that bit there. Unless something's not switching it right, but I think that's foobar. The way to tell it is if I desolder that, and then we'll do some resistance checks on it, we should be able to work out whether it's got open circuit. There's a couple of other bits we can check as well. There is another diode there. I didn't spot that one. So unfortunately, I can unclip it. It is unplugged as well. Anyway, let's it's not playing ball coming off. Unfortunately, because the hole that you prod to pull it off is on this side. It's got a locking tab in it, but unfortunately the locking tab, the where you press it, is on the other side, so you can't actually get to it. They've put the thing on the wrong side. Which I'm finding very annoying. Right, got that off. We'll trim that down somewhat. Right, let's see if we can work on this a bit better now, because it was very difficult up there. So I need somebody to do camera work for me. So we've got another capacitor here which we haven't tested, and that is 4.7 microfarads. So that's interesting. Really struggling to read that one. Let's try it the other way around, just make sure I'm not reading it wrong. Briefly read it right there. That's interesting. I'm going to have to break that one out as well. There's a diode there. Across those two. So, oh. That's okay. Nothing that way. So that looks okay. I'll just check that one again now. We've 1.8 volts that way. So that doesn't seem right, but there is a load of stuff there linking them together. 3.8.38 volts. Yeah. So what we're reading there is those the capacitor and the resistor there, which is why we're getting it in one way. So I think that's part of the smoothing. We've got two capacitors there that we can't read as well, because I think when we try to read those, we're picking up that resistor that goes across there. There's a resistor there, capacitor there, resistor across the capacitor, another resistor. So there's a whole load of them bridging across it. Yeah, 3.8 volts again. So I think we're going to have to possibly pull that out and have a look at that. So it was thing to the back. I don't know where my solder sucker is either. I think Jacob might have that. Come on, it's going up, 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 up. Come on, quick, 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 quick. Yay. No, that's okay. It's not reading anything one way, it was reading 0.3 the other, so I think that's okay. And it's an SR 51000, whatever one of them is. Right, I need a bit of, we got some solder mop. That's me low melt solder, we don't want that. Have I got a solder sucker? I think my son has stolen my solder sucker. Guess it's in here. No. Is he under there? No. I don't know where that would have gone then. Right, let me go and get the solder mop. Solder mop. Going to go in because it's full of solder on its tips. Ow, 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 ow. I don't know what I thought was going to happen when I did that. Put it where you can see it. could do with more of a pointy point on there. Right, let's pop out one of these. That's barely hanging by a thread. I think my tip's working loose as well, which isn't helping. Come on. Happy if I was unsoldering the right bit. I can't get this bloody thing to come undone. I don't think this tip's big enough. Right, let me go see if I can locate my solder sucker. Right, retrieved the solder sucker from number one son. Got the second one out. So bearing in mind these are a bit hot, so they might give slightly odd readings, but you can't see the gauge, but it's calculating, calculating, calculating. 462. That's somewhere near. Let's try it again, just make sure. That's fine. A little bit low like the other one. So we'll just have a quick tidy up around there. They are the two outputs, so we were right. So while we're here, we'll just measure the resistance across those. Now we've got the yeah, we've got a dead short. So unless I've managed to bridge it across there, I'm pretty sure we haven't. I'm not entirely sure how it gets from there across to there, to be honest, but let's desolder that while we're here. Pull that bit of the cable out. No idea how Buy It Fix It manages to get his stuff to stay not wobbling on the circuit board. There it has dropped through. We'll do those, we'll get a bit of a solder mop on there. Flipping heck, how much solder's in there? Right, now we can see if it's got a short or not. Yeah, we're not getting anything there. If we read it on the other, so I'm getting something there. I'm getting like 0.3, 0.4, 0.3. Consistent. 2.1 on that one. So it's like we've got a dead short on that. Yeah, it is a dead short on that. The question is, do we want to try and fix that, or do we just go and buy another power supply? See if we can find a a circuit board power supply that will fit in there that's about 1.5 amps. 12 volt output of 1.5 amps. Because I don't think we'll find that transformer there. And the input's 300 volts, the output's 12 volts, I'm guessing. The output might be higher and it gets stepped down through here, but it looks like that pretty much on the live side goes through to that one, and then everything that's on the other side is just I'm guessing switched off that diode. Yeah. I'm not entirely sure how it gets from there over to there. How does it get from there over to there? That's a good point, actually. So, oh, you can get any closer to this, but power's coming into the transformer on there, and its exits on those two there. They are the only two pins that are soldered on. Right? There's nothing else. You can see there's nothing else under the circuit board. So this comes through there and gets partially rectified going through that diode there. Right, now there's also a connection that goes through a big resistor there, 390, which I'd have to calculate that, and then a capacitor there. Right, and then I think that is, could be wrong, no it's not, I thought it was all part of this, oh it is, yeah it is part of the same circuit. So if it has to be really, if I put that on there and that's going to be a, yeah, but it's not to there. So somehow, so that's all one buzz, kind of one bar across there, but then somehow this power gets from here to here, but I don't know how it does that. Now there's a capacitor across there and a capacitor across there, which then takes, right, so that's it, yeah. Which then feeds that one. So if you imagine it's alternating current, the current comes through here, passes through there, travels through to that one, and at the same time it's charging these capacitors. Then it switches back the other way. It can't flow that way because of the diode, right? And at that point, as soon as that knocks off, these two capacitors here discharge and then power it through there. Which is the return. But it still doesn't tell, right, yes, because that's connected to there. Yeah, so that's it, that's how it gets back. It gets back through the capacitors onto there. And possibly a resistor. So the only thing we've got to be careful of is that we don't, there's nothing there that's bridged, that shouldn't be bridged. But that is connected. I'll put money on that's connected as well. No, that's fine, they're not connected. That should give me a resistance reading, that's not a diode. That's a resistor. Aha! That's a resistor, it's open circuit. Aha. 3, 9 and a 0 is 39 ohms. And that's what I'm getting on that one, 39 ohms. What I can't read is what they are. Right, 2, 2, 2, 2, 2, 2. So I think that's 22,000 ohms. Nothing. Nothing. So I think all those 3 resistors there are blown. So there's absolutely nothing there. Well, that's interesting. No. Every one of those is blown. Yeah, that's never going to work. So, I think we've got to the bottom of it eventually. Getting absolutely nothing on those resistors. All of them are blown. They're all open circuit. Right, they're knackered. So I think we'll just try and get another thing, because by the time I've faffed about trying to replace all those 3, with the limited resources I've got, I think we're going to be struggling here. I'm pretty sure 222 means 2 zeros, so it's 22,000. But we're not getting anything anyway, so it almost doesn't matter. Interesting. Right, so just so I remember where we are. I really must get some wire strippers for down here. Right, we'll just tin this up. Will do. The other 2 are there. And we'll drop these back in as well. Set that up there and let it rest on there. It should be okay. Has it fallen out? It's fallen out. The neatest bit of soldering anyway. What are you moaning at? Stick you in. Bend you over. Yep, Future Mark's not going to thank me for that one. Soldering's getting better anyway. IPA. Acetone. I need some cotton buds really. Oh, I know what I've got. Some there. I've got. Maybe I have some more. Maybe I'll use more. I found that's it, that looks a bit better. I can see them now. So I think that's what's up with them. I think those resistors there have blown. Oh, it says as it's now getting resistance on them. That's right, 666. So all of a sudden it's decided it's going to work. So they're in the banked parallel. So when you parallel, you add them together. When they're in series, it works the other way. So that's interesting. Right. I might stick this back in and just wonder whether it's just one of those things where we've had a bad solder connection or something. Can always take them back out again afterwards. I think the black one went to the back. Right, let me set this. Right, I've just touch soldered those two wires back on. We'll stick this one in here. We'll stick this one on here, but we'll make sure we put it on the right way round this time, not the wrong way round, so I can actually poke the fucking thing out. Sorry, excuse me French. Right, be interested to see how that pans out. That was just going to work. No. But what we can do now is I can probably get a decent now, I'm not getting voltage, I'm just getting resistance again. I'm just reading the resistance across there. So there is absolutely nothing coming out of there. It's just effectively a short. If I go and measure on yeah, 3,300. What I don't know is what that chip does there. Turn that off. See if I can actually read that. Took my spare glasses off, haven't I? Where did I put them down? Oh, they're over here. This is why I like the experience of somebody who understands, who does this regularly. Because they would just look at that and go, oh yes, it's one of them. Can't read it. Right, we're all learning together. So, normally your high voltage and your low voltage, or your mains voltage and your DC voltage is split. Alright, so we know we've got high voltage coming in, we've got low voltage going out. And normally it's split, the bulbs are side. Now, these are intelligent power supplies, so they have the ability to turn off the power to this when there's a problem. But it's still going to maintain isolation. So how does it know there's a problem over there? Because if there's a problem over there and you get a problem, you'll end up bridging the two circuits with high voltage and low voltage. So it's got this thing here, right? So I've looked it up and it's an opto isolator. That's an I can't remember what it was, but it was an EL817. So it's an electronic isolator, opto isolator. So what it is, that's port 1 because it's got a dot on. So that, when there's power coming through here, inside there, that's an infrared diode. And over here, there's a receiver. So if it detects that infrared diode in there, it gives a positive feedback on here. So you can test that. Now, what I should get is the behavior of a diode on here. So when the red pin's on there, and I've got this set to diode check, right, which is that. I could do a diode check on this. I should get a voltage drop of about 500 across it. Oh, I am actually getting a voltage drop now. Right? When I test it the other way round, I shouldn't get anything. And I am. So I'll just be reading how to test them. We'll show a voltage drop reading between approximately 500 and 1100. Reverse the probes, placing the black probing pin over. There should be no reading and I should get an open circuit. If you get a reading in both directions or no reading at all, the LED is faulty. Right? So I'm going to pop it off the board anyway, because it might be that it's on the board that we're getting a problem here. Because we are turned off, so there shouldn't be anything on there. But I'm getting something the other way. I shouldn't get anything, and I am getting 1.8 volts drop. When I go on this side, I'm getting what I should get, but I'm not getting it on this side. So I think that diode, so that could have failed, and it's not, so therefore it's not getting the lights, therefore it's switching off that power supply, and that's why it's not passing it across. So I'm not ready to write this one off yet, but obviously I'm going to have to order one of them from somewhere. So we'll get it off, we'll test it, and then I suspect that's it done for today. Let me do the sensible thing now. Plug it from the mains before we do this. It's not turned on, but let's not risk it. Right. I'm conscious that you won't be able to see a lot with this one. Come on. Don't let me get the solder sucker in there. Come on. Right. I need one of them super zoom cameras like what's his face has got. Right, the dot's there, so that should be the one what I'm getting. So on this bit I shouldn't get anything, and I am getting, sorry, no, I should be getting 1 point that, because that's the positive one. So if I, that's the dot, yes. So this time if I do it the other way round, so the black probe's on the dot, I should get open circuit. Oh, I get open circuit. That's fine, so it must have been picking something up off the board, so that's okay. So that is working. And we should get a resistance on the other side. I forget what it said that we should get, but I can quickly measure it and then we can go and get it anyway. Ah, that's interesting. We are getting an open circuit on there. I'm getting an open circuit on there as well. Oh, that's interesting. Let's check that again now and confirm we are definitely on that side. So actually no volt, that's not right, is it? Right, that's what I need to be testing for. Right, I'm getting nothing there. Yep, it tells it's gone open circuit. So it does look like the opto-isolator's failed. Oh, I wish it just stays still. Nope, dead. So that's interesting. So we need one of them, at least. Right, so we will call it there now. We'll pop this back in here, and we will order up one of them. And in the meantime, we've got something else to look at. So just a quick recap, because I'm not sure if we got that one. We got the opto-isolator out. We checked it on the LED side, because there's an LED on one side that emits infrared. There's a collector receiver on the other side, and that's how it provides a feedback loop that the transformer is actually working and it's on, so it doesn't switch it off, which is what I suspect it might be doing. We're getting voltage in, but we're not passing it through, but it's quite possibly that there's a thing. I mean, we could drop a resistor in there to simulate the resistance of that, but I don't think that's a good idea. I don't know enough about this to do it, but we'll order one of them up, opto-isolator, not very expensive, about £1 off Amazon, probably get a box full of them for something like that. There you go. I can get for 43p for God knows how many. They sell on Amazon. I think they sell the whole opto-isolator unit on there. E817 opto coupler, 10 pieces for £11. I think we can do better than that. £3 for 10. There you go, arriving 23rd to the 31st of December. I don't think I'm that bothered about them. Whatever happened next day delivery? I'll have to have a look. They've probably got some on Amazon I can get fairly quickly. Right, I'm going to cut it here. We'll come back when we've got one of them. After that, I think we're going to scrap it and just see if we can pick up one of those power units. So, found a part on eBay that's on 2 to 3 days delivery for about £3.90 for 10 of the things. That seems reasonable enough. We'll just shove this back on here and stuff that in there. I don't think it was fastened down. I think it was just rammed in. Which says a lot about these things. I don't want to lose the screws. That's the problem. Equally, I don't want to lose the thing either. That'll do. just put these in loosely. It's just so I don't lose the bits, because we've had these screws and stuff kicking around on the side for ages. So that should come in next couple of days. Like I said, I know I've learned some stuff quickly. I'm not just saying that. I do assimilate logical stuff quickly. I've always been interested in electronics, but not to the point where I could, you know, be bothered with it. I had friends at school that were into it. They could, you know, just pick up stuff and just build circuit boards and logic. But I've been watching a lot of that Buy It Fix It stuff, and a lot of it just makes sense to me, because it's kind of like programming. And to be honest, it's where programming came from. You know, so all the stuff you do in programming is just condition. If this equals this, then do this. And that's all electronics is. It's just, if this voltage goes above this, then route the voltage down this thing. You know, and that's how computers were built. So a lot of this does make sense to me. So I can learn it, even though I'm old. So I kind of knew there must have been some kind of a feedback thing to tell it that it was off and to turn it off. Otherwise, it just keep chucking voltage through and potentially catch fire. But if there's no voltage coming out the other side of the transformer, your transformer's going to potentially just be an electric fire. So you've got to be able to shut it off. So it's got to have a feedback loop, but you can't bridge the two voltage systems. You've got to have a physical break. So the only way you can do it is to pass the light source. So that makes sense to me. So that optical isolator would explain why that power supply is not chucking the voltage across to the other side. So it makes sense to me. Whether or not I'm right, you know, it could be the thing that's broken anyway, and that's blown. But that's blown because it sent too much voltage through in the first place. But who knows? Like I said, my skills for doing this kind of thing in the past has been limited to basically to soldering up radio controlled cars and radios in cars. So, you know, I'm not skilled with the soldering iron in any way, you know, and this soldering station I've got is a cheap and cheerful soldering station. I can't see the point in buying anything expensive, you know, and I'm not going to get into the point where I'm unsoldering, you know, ICs from circuit boards or anything like that. I'll get to that point, I'll just buy another one. It's just more of a hobby curiosity to me at the moment. I've already managed to make a mess of that. Look at that, I've melted it already. But anyway, we're gonna call it there. I could do with another box for this stuff. I'll just chuck it all in there and hope it doesn't get lost. I've got another thing to look at, so we'll do another video on that, which will be the one that comes out. I have got these to look at as well. So, I don't know if you can remember these. I don't know if I did a video on them, but not the glasses. These are the LEDs we used to have on our walkway. Really nice little unit. That bit screws to the wall. The wires come in, they clip into that, and then the light literally docks onto it, and you screw it in, and it gets its power from that base thing. Really clever idea. But they all started to die after about a year, one after another. And I think I ended up with just one of them working. So what I'm going to try and do is either fix some of them or get one of them working or two of them working with bits from the others. Now I suspect with these, one of them was completely foobarred, it would just flicker every now and again. The others were very low light and one of them was working. So I suspect an LED's gone on the bank. So the light's still working, but it's only working on one LED. Similar thing with this. This started playing up, it started getting worse and worse and worse. So I'm tipping when I get this off, which actually looks like we might be able to do here. I'm tipping we'll be able to see that one of these LEDs or many of these LEDs are blown. And that's what's up with it. Of course it could be bonded on. Yeah, I suspect that's bonded on. We're going to have to get the heat gun on that. I didn't think I'd be that lucky. But I suspect it'll be the same thing when we get this back cover off, which it might not. Looking at it now, that's glass and that might be glued on. But I'm tipping we'll find one of those is dead and it'll be right at the beginning. And that's what's caused it. So again, we might be able to repair this because this was quite a nice light as well. Quite small form factor. Worked quite well, kind of thing. Not entirely sure what's going on with it, why that's facing the wrong way, but that's better. that was our main path light for ages and ages and ages, and then no, it wasn't, it was the garage light. It died, just started flashing. But anyway, we'll see if we can fix that for the same reason, because we do need another security light outside, and they are quite expensive now. But these would be nice because they're nice and subtle and they give it's not a blinding light. So the idea is they go on the side of the garage, so when ourselves and next door, we shared a path. When we come down, they just nicely light up so you can see where you're going, because it's not bright at the moment, and I fell over last week and twisted my ankle. And obviously I'm an old person now, so I need to be careful with stuff like that. But anyway, right, I'll just clear this lot up. We'll close this one down until we get that part coming in, then we'll pick this one up as a part 2. But I'll probably do it in one video because there's a lot of crap I can cut out of this one. I'm going to go have a look at the other thing. So I've got an iron over there. We've had it for years and years and years. My wife does not iron, but every now and again we need an iron. So I've got to fix it. I think it's just probably scaled up, but it's a really posh one. It's a Morphy Richards generator. The history behind why it's a Morphy Richards, because my wife used to work for Morphy Richards, and we used to get parts and things really, really cheap, because her mum also worked there. So even when my wife stopped working there, we were still able to get stuff really, really cheap from Morphy Richards. But we'll have a look at that in a minute. Right, see you in a bit. Whoop. Oh, we're back. Let's just move you slightly. See if that's any better. Sort of. Right, we're carrying on with this light. It's okay, this one's been about a week or so since we last touched it. Yeah, that's why we've got it like that, because it's a pain up the backside. So just a quick recap what we did with this. We had it to pieces, which I need to do that again. So we need to get it open. We need the blue mat. Let's get the blue mat out. And get this off again. So I just packed it away last time. Well, you know that because it's like seconds for you. It's over a week for me, so I'm just recapping in my head what we've done. Right, shove that over there out of the way, and let's get this back out. I don't know whether I want to. Do I want to unsolder it? I guess I'm going to have to, aren't I? Because I've got something I need to. Yeah, what I need to get in needs to go in there, because I think that is what had blown. So let's disconnect the main wires, and then we might have to just unsolder these wires that we quite nicely soldered back in there, because I don't think there's any way I'm going to be able to get to the so remember that it was the opto isolator that we think had gone on this. It took an open circuit on one of them. There's a resettable resistor there, a thermal resistor. It's a resettable fuse basically. I think we need to get them off, so I'm going to have to plug the. I was trying to avoid doing this. That's what the problem is. I don't want to do it. The other thing is, can you hear me okay? I'm going to press record on this just in case, because we've fallen for that one before. So we'll quickly get that unsoldered. I'm a bit wary about how close I am to the TV there, but I need the power supply that's at the bottom of the TV. What we also got, so let's bring you a bit closer. Trying to get the whole mat in. So, I found these on eBay. I think I told you about them earlier in the video, and I ordered these. Why I've got that, is that what I want? I'd already taken them out. So we've got a couple of these. These are exactly the same as the ones that went in. I have tested them and they do appear to work. So I've got loads of them, so even if we blow another one up because there's another component that's broken, we still got them to go at. While I was looking, I also found this, which I don't know if I've got a knife in here. I'm going to go find a knife. Keep talking amongst yourself. Mark walks off, gets things because he's not prepared again. So we've also got this. So if you compare that for that, you'll see there's a lot of similar parts. This is a 12 volt, 2 amp, 15 watt power supply. Switching isolated power supply. It is exactly the same as that basically. You'll recognise a lot of the components. So the same transistor. We've got diode, resistor, opto-isolator with the opto-isolators down there on that one. We've got a plug or a soldered in input. We've got an LED on this one. Ooh, posh. We've got the 2 capacitors, and I think there's another capacitor there as well. Then there's the smaller smoothing capacitor. Then there's the main capacitor that it's using as part of the is there anything else missing on this one? I think there's an extra diode on this one that we've not got on this one, but that could possibly be covered somewhere else. That's the same. There's a fusible link thing there going on as well. So that's your live in. That's your current out. So that's the main rectifier diode there, and that's the opto-isolator. So what we've got to do is unsolder that and put a new one of them in there. Now I might try and do it on here, to be honest, to see if I can get it in without having to unsolder it, and then we can just test that. If that still doesn't work, what I'm going to do is I'm going to chuck this in. Now my only concern is that it might not fit. No, we've got a good fit. We've actually got a scroll there. We can actually mount it in as well. So whether or not the other cover will go over the top of it is another matter, but I think we're okay actually. It's a little bit higher than that one, but we'll see. Yeah, I think that's going to be fine. What's the eldest? Can I have some hot water, please? You certainly can. The beauty of Hive. Hey Siri, boost hot water. There we go.
Done.
Thank you, Siri. Didn't work for ages that, but it seems to be working again now. Right, anyway, back to this. This is up. Let's get the solder sucker. Let's see if I can get this opto-isolator out. Just for me, I just need to take a note of where it is, because there's a can't remember where I saw it now. I could have sworn that was it. Have I dreamed this? Just get bought some bloody eyepieces because I'm sick of doing this flipping blind all the time. It was there. I've already taken it out, haven't I? I was just trying to see what this was over here, but it's not. It's there. So yeah, and this has got an opto-isolator on it there, but it doesn't have that other rectifier thing going on up there. So there might be a little bit more to this one, but this one's got more power. The other components, the missing components are on the bottom. So there you go. There's the transistor. It's there, and there's the other thing that I couldn't work out what it was. I think that's possibly a rectifier. Don't know. Like I said, I'm not that good at this stuff. So that makes life easy. All we've got to do is stick one of these on. So that's become an easier job. Pin 1's marked there, and pin 1 on these is denoted like most chips with a circle. So as long as I can get this in here into the same holes. Look at that. Looks like it's exactly the same thing. Oh, it is. Now, what's the state? Oh, they're all blocked up, that's why. All right, let's get some solder mop on them. Solder mop. Don't know if I need any flux on it. That appears to be working nicely. Yep, they've cleaned off. Just need to be a little bit careful with this one because we've got a resistor next to it. Cool. That went surprisingly well. Got some flux, because the flux I was using before was just a tub of it that you stuck your thing into. It was more for kind of when you're doing car soldering. Oh, there we go. Nice. Doesn't want to come off. Oh. That'll be why then. Am I supposed to pull that out of there? I don't know. Or do we just ram this in? I don't know. It's all part of the fun and games. You've never done anything before. I know you lot will be screaming at me going, no, you do it like this. Danger. No. Absolutely nothing. There's a hole in the middle of it. I'm wondering whether you use this to get it out. No. So that just doesn't seem... Anyway, see if we can get some on. I'm now wondering whether I am supposed to get this out of here. I don't know if it's coming or not. Oh, I think it is. There we go. Yeah, I think you're supposed to get that out of there. Do you know what? I honestly don't know. I don't think you are. I think that is supposed to stay in there. Yeah. Am I supposed to unscrew something from the end of this? Who knows? That's it, we're getting the hang of it now. Right, I think that's what you do with that, to be honest. And then you can take that off and screw that on there and shove that on the back of there again. Right. Part. So where's pin number 1? Pin number 1 is there. Get that straight in there. So I'll turn that over, get my let me just check I've not bridged that stash of cotton buds. So I can clean the oops, come on. Carmen's moaning at me. Let's give the board a quick clean off. Right. I'm interested to see if that works now. Let's plug it back in, make sure we put that on the right way round so we can get it off again. Clip. And that goes on there. Right. I haven't got a dim bulb tester, so we'll have to make do with this. I have to be careful as well because the soldering iron's still turned on. That's off. Right, see if it works. Well, that was a resounding no, wasn't it? Right, we off? Yep, we're off. Right, just need to be careful because that's going to be charged up. I just want to see if we're, because it could be I've just soldered them in the wrong way round. So let's just see if we are getting any voltage out of it. Common, you alright Ricky? Still with us. We had a bit of a scare the other week with him. He's old, he's about 15, he's coming up to 15, he's a Spanish water dog. They generally only live to about 16. So he's kind of on borrowed time. Alright, let's just see if we're getting anything. No, we don't want voltage. Let's have a look, see if we've got anything on. No, doesn't look like we've got any voltage. We actually turned it on now. Yes, we are on. Not getting any voltage. Not blown the fuse, have we? Yeah, we're getting voltage in. We're just the same as before, we're not getting anything. Nothing. Right, let's go to plan B. We'll have a look at that later. Let's just get it out of the way and get the other one in so I can get it back to my missus and get it off me workbench. So all we've got to do is put this in. Fortunately, it's nice and easily wired up, so we just got to let those that big capacitor discharge, because that's still got 181 volts. This is actually draining it nicely. 120, 90, 80, 70, 60. 25, 24, 23, 22, 21. I think that should be safe to operate now. Let's have a look. 11 volts. Ricky, why are you obsessed with digging in my bag? Oi, pack it in. Right, they're going down nicely. Right, let's just desolder this then. So, right, it's first one's first. It's that one there. So we'll just let's try and get this one out. Work out where it goes. Oops! Don't touch the screen. Right, I think it's that one. Right, so what I've got to do now is just disconnect this and unsolder that. Right. So annoyingly, I don't think I've got a way of... That's the old one, isn't it? I don't think I've got a way of putting a spade connector on here. So we've got live and neutral out, and then we've got... Sorry, live and neutral in. I suppose I could put a... Yeah, we could take that out and put a spade connector on there for the neutral. I think they're about the same distance apart, aren't they? No, slightly over. Let's just let's not use them. Let's go and get the proper tool out of the toolbox. Or one of them, because I don't have the proper tool. Yeah, I do need a pair of wire cutters the wire strippers for down here. Actually, I thought we'd got some in the... That's gone quite nicely. That's it, it's tinned up nice. Alright. So I think we'll send them through from the back. Let me just move that out of the way and Oh, it won't reach any further. I was going to get the solder station's got some little handle things on it. I think we're just going to have to just put a tad of flux on there because it is just fresh metal. That's it. That didn't want to take. I don't think I've got the right tip on. My soldering skills are not good, so feel free to take the piss all you want. I won't be offended. I think I said it in the other video, my soldering expertise has been fixing stuff in desperation. Could do with a solder mat for that. I don't know where it's gone, there used to be one in it. Going on my nerves, that is. It's got a little blip of solder. Perhaps I shouldn't have. Oh, come on, this is getting ridiculous now. It's getting worse. Come on. I have to mop it in a minute. Oh, it's sprayed out, that's why. Let's go again. I think I shouldn't have tinned it first, I should have just sent it through the hole. Now the insulation's got warm, it doesn't want to. Right. It's coming out there and I couldn't see where it was coming out. Fantastic bit of soldering. I think that's okay. Right. What I do need to do though is work out where's my diode check? Alright, because these are LEDs, so we should be able to do a diode check to work out which one's positive and which one's negative. So black is negative, I think. Not getting either off it, or any of them. Interesting. How do we fix that then? Let's just get the power supply out and make sure we've got them right. I think the black one went to the back, but it doesn't say which is positive and which is negative on this, unfortunately. I would say that's negative and that's positive. I'm going to go with that. I think we're safe. I think we're safe to assume it was. We can just switch them round afterwards. Right. So positive is that one. Another one that doesn't want to go through, bloody hell. Right, let's do this one first, because that's closer. Getting just a little smidgen of flux. I can't see a flipping thing. That's the world's worst bit of soldering. The power supply wasn't actually that expensive. It was, I think it's cost me £3 to buy 10 opto isolators, which it may look like we didn't need now. Just touch that one up a bit more. That's better. It's a bit of better soldering. Right. Let's wind you back a bit, because otherwise you might get blinded by this, hopefully. And we are off. And, right, so that's all in place. Let's have a look. Oh, we've got a light. Well, that implies it's working. That implies I've wired them up the wrong way round. So let's just have a quick... Oh, we're still on voltage, aren't we? volts. Positive, negative, yes. So I suspect these are, I've wired them up the wrong way around. Turn that off. It's taking ages for that light to discharge. Obviously it doesn't discharge as quick as the other one. Where's the big capacitor, I think? I don't want resistance, I wanted voltage. It's that one and that one. The light's gone out now. We're down to safe volumes. Right, so I'll switch these round. Obviously I've got them the wrong way around. So this one wants to go in. There. Shouldn't need any flux on it this time. Might need some solder wick or solder sucker. Let's keep with some solder sucker. There we go. Gotcha! Right, let's try it again. Hey! Right, brilliant. We can pack this one up now. I still want to try and work out why this one doesn't work, but we can play with that a bit now. We've put that in the right way, haven't we? Yeah, I'd be interested to see if that's still intact, whether that's I'm just waiting for the voltage to dissipate off that one. So on this side we should have what's a diode. So we should get one diode check. That's the positive. That's the negative. Yep, that's good. That's what we should get. On one side, and then we've got the receiver on the other side. I think it's still reading some residual voltage here. Yeah. Let's read. That's interesting, I'm reading a short. Nothing that way around. Oh, might have been. No, open circuit. Don't know what to make of this. I suspect, if I had to guess, it would be it's that transformer there that's died. But anyway, let's get this one put back together, and then we can send it on its way at least. He says, hopefully. This is where we find out that this doesn't fit. The old component in there. I've got to shove that in there. So we've got to find somewhere for that to live, and that's not going to get in the way. And equally for this, we've got to find somewhere for that one to live that's not going to get in the way. So that's both of you down there. You can go there. We might have to snap that lug off. If I can't get this over, we might have to snap that lug off. That's it, we're out. Oh, brilliant. It fits. Actually see what types of screws these were, and we've managed to lose one of them. Are they Phillips? And that would explain why we're trying to do it Phillips with a posi. I want to Phillips. You'll do. You might think it doesn't matter, but ask anybody who's ever owned a Japanese motorbike second hand and ask them whether it's important to use the right screwdriver for the right screw. Because the Phillips screws that are in there aren't Phillips screws, they are JIS. Right, it does need a bit of a clean actually, because I did throw stuff all over it from when we did the iron, which you should have seen, because I think that went live last week as I'm videoing this. I'm assuming this is going live next week. I'll give it a bit of a clean for her. I don't know what she's been doing to this, because this actually looks in worse nick than the one I've got in the office, in the workshop. So I don't know what she's been doing to this. Oh, I know what it was. It was out in the chicken place where she fixes chickens, where chickens go to be mended. So yes, it's probably covered in all sorts of bits of dead chicken and all sorts. Right, let's have a look. You can have a peer down here. Ooh, look at that. Oh, we like that. She might not be getting this back. So it's such a simple thing. You could almost take every single one of the components off here and do it. The trouble is, I don't think you've got the right. Yeah, you need it there, which means I need to then put my head over. So if I move that to there and move that to there, can you see it anymore? That's better. Right, let's get rid of that. Didn't take the whiskey bottle out. No, there's no whiskey bottle over there, honest. It's an amaretto bottle actually. Right, unscrew that. Screw that back on there. Let's be nice and tidy. That can go inside there. I think we're all good. That can go live in there. Right, let's get my testing station out. I don't think you can see that, can you? I'll put it there. If I put it there, you can't see it. Yeah, the trouble is you're getting a halo effect from that. The light needs to be behind the camera, not in front of the camera. But anyway, let me have a look. So we've got some components. I think we checked the capacitor. Right, so we checked the capacitor last time. Don't do this while it's charged. So the capacitor is those two. Just thinking about it. 21 microfarads. What does it say? 22 microfarads, so that's spot on. We've got what looks like a guessing a transmitter, a transistor, but it doesn't say. CS2N2F. Is that corroded? That looks like it's corroded. Is that transistor blown? Alright, let me get the... I don't know if you can see that. Set it going again. Right. We've got a CS2N60F. I think that's a transistor. Could be wrong, could be a MOSFET or something like that. But it looks like it's full of corrosion. So I think we might get that out of there. So number 1 pin was that one. So it's flat like that. Just loosen these up first. Satisfying. Not very satisfying. Still not very satisfying. Come on. I think we got it. Last one. Yes, that's corroded. Right, I don't know if you can see that. It looks like it's corroded, or it's got the, or it's covered in that conformal coating that they. No, because there's no conformal coating on this, so I think that might have died. But it's, why has it got corrosion on it? I mean, I know it's damp in that room, and I know mine in the workshop died as well because of corrosion, but it does look like there's corrosion gone up into it as well. So maybe something has gone and it's blown apart. So let me just turn that off and get that out of the way. And we'll look up the specs on that and how to test it. I can't see a bloody thing now. Right, so I've got it out, I've got the data sheet up. So it's ground, drain, source. So I need to put the red probe on source and the black probe on drain, and I should get something between 4 and 9. Now I've got 5.5, so that's good. When I do it the other way round, on the drain and the source, I should get an open circuit. And then in theory, if I test across from the ground to the other pins, I shouldn't get anything. Just check it the other way round. So I think that's okay. Despite all that corrosion on it, I think that's fine. So we need to get that back in the circuit board. I know I should be soldering on that bit. It was a MOSFET. I was right first time. So that's that's about as good as we're going to get with that. So there is a very tiny, some kind of an IC down there. I can't see what it is. That might be something to do with, oh, hold on a second, why didn't I spot that earlier? We might have a track out here that might have corroded. I don't know if you can see that, but that track all the way along there looks like it's corroded. Let me get me something I can scratch with. There we go. Oh, I can see copper underneath. I've got a bit of a dry solder. Trouble is I can't. No, it looks okay. It looks like we've got something that's going all the way along there. No, it's now made me wonder whether we've got anything else like that though. I think what I need to do is slap a couple of wires on there, connect them to a 12-volt light bulb or something like a car light bulb, and then put a mains in here, and then we can just keep mucking about with it. But I suspect this might be another video now. Don't really want to spend much more time on this one. So there's a few weird capacitors and things there we could test. We tested all them last time. Those three things there. And then we've got there's that IC down there that I can't read what it says. This is where I need a magnifying glass, but I'm not going to buy one of those desktop magnifying glasses. And then we've just got this stuff on this side, which is all fairly basic stuff. We haven't tested that resistor, have we? I'll have to do a calculation on what that is. I don't know what that component is. We'd have to look it up. Could be another capacitor, I suppose, but it's got no capacitor reason. I think these blue things here, that one definitely looks like a thermal cutout. MYG10561, or it's just a resistor. It says it's an R1, but sometimes they're like thermal cutout resistors. They have an auto reset. They cut out and then they reconnect. Yeah, so that is negative, isn't it? And then that as it turns out, that's positive. We tested that. The only thing we haven't really tested is that. Other than we've done the resistances on there and we've done the ohms across there and there. I don't know what that one is. That's got a weird code on it. Oh, it could be a 130 plus 3. Unless they are E's. So that's 130,000 ohms, I think, is what that means. That's a 24,000 ohms. Kilo ohms. So that'd be 130 kilo ohms. Don't know. Let's test that. My reading of these isn't very good, so don't hate on me. I am new to this. That's weird. I'm not getting anything. Oh, that's interesting. Unless it is that way around and it's something else. No, it's definitely a resistor. That's open circuit. Oh, that's interesting. That's weird because that's open circuit as well. Falling into some conformal coating issues here, are we? That whole track could be broken. Mind you, that one's broken as well, and oh, hold on, no, we were going to get something then. 33. I think that's what that said, 33. Something like that. So that one's working. That's open circuit. Yeah, I think this isn't worth saving it. If that's open circuit there, that's working. So we've got 33 on that. That one's blown. That one's blown. That one's blown. 10. Yep, that's fine. That's a diode. So that should be open circuit that way. I'm not going to get anything testing that, am I? What else have we got? We got these resistors here. So I'm not getting anything from them either. Nothing. Nope. Yep, they're all out. So yeah, this is what makes me wonder whether it's something with how I'm testing it, but it's not, because there's definitely, so they're out as well. I think we've just seen I think what's happened is that something's died and it's taken all the resistors out. That's the diode again. See, that one's dead. That one's not dead. That one's dead. That one's dead. Or if we trace it back to the no, they're dead. So that resistor there's gone. That resistor there's gone. That resistor there's gone. Them resistor there's have gone. So this is all on the main side. So I think we've had a spike or something. Or we've had a short on this side somewhere that's taken out all of these resistors on the main side. I'm struggling to see what that would be. Let's There's nothing across there. Ah, we've got a short. We've got a short on that, so that's shorted. See, I'm getting 1.5 on that. A dead short on here reads 0.1, so... Oh, I'm getting a reading now. Weirdly. Why didn't I get that reading before? 1.5. So it's not short. Open circuit, open circuit, open circuit. No, it's not that then. Nothing across there. Something's taken out all these resistors. So I'm not getting anything across that thermal fuse either. See, that goes from there to there, so that's dead as well. Which is weird. Yeah, I think we just chucked this in the bin, unfortunately. I wanted to try and fix it. But it looks like that's gone as well. Possibly this thing here, whatever it is, a DB170. See, in my head, that's some kind of a diode block, is what DB could stand for, but I think that's kind of a rectifier. So let me have a quick look at what that is. I must be getting better. I was right, it's a bridge rectifier, which makes sense. So if the bridge rectifier is blown, it's going to have sent everything through here. It's going to have taken that out. It will have taken these out. Yep. So the bridge rectifier is blown. That's what's blown. That's blown and taken all the things out. So let's desolder that just for a laugh. I don't know if we're going to get it out though, because I think that resistor's across the top of it. But I might have to take that out as well. Let's just try. Dog's snoring. Want to do that, folded the leg over. Where's me solder mop? Don't use your probes to pry things out. that's what I was feared. It's kind of stuck underneath. Oh, we got it. We've got her. Houston, we've got her. Oh, we've not affected it by splidging it. Right. So alternating current on this side. It's got helpfully. I don't know if you can see that. It's got some. On that side, it's got two squiggly marks because they're obviously not polarity sensitive because they're from the mains, and then on that side we've got your plus and minus. So in theory, if we go from one of these on the we're in resistance again, we don't want to be in resistance. That's it, back to diode check. Squiggly bits over there. So that checks out. That's open circuit. So if I now put that on there, I should get open circuit. Oh, we haven't got a short. I've got a diode read in there and nothing there. Actually, that's okay. So this time I should have nothing. And no open circuit. I think this is okay. Let's just do a short test. Oops. No, I think this is all right. Let's put it on diode check again. So mains voltage side to there, we get a voltage drop across there. We don't get anything. If I'm on this side, we get a voltage drop across there, and we get nothing across there, so that's fine because that's positive. That's negative. If we flip these round, we should get it the other way round. So we should get a voltage drop on there, nothing on there. Voltage drop on there, and nothing on there. Correct. So I think that was all right, but I've absolutely mullered it getting it off anyway. So I think we chuck that in the bits box. I'll try and solder this back on, but I don't think I'm going to get very far with it, to be honest. Plus and minus there. I think that resistor's kind of in the way. Don't know if I can be bothered to try and get that off. So we'll put it back together, and then I might pull it out later another day. I'll be honest, I've got a little bit too much on at the moment to be mucking about with this, which is why I needed to get this off the bench and back upstairs. Though I'm thinking I might go and rescue mine out of the workshop. Weirdly, if you remember, mine did this in the workshop as well. It packed out, but then it came back to life. So I don't know if it had the same fault, but they were from the same place. That's not got anywhere near enough. This one doesn't want to let go. Sold them up. Don't know where it's gone. Let me see. Can't see for looking. There we go. Got the bloody thing out now. Right. Let's chuck that back in. A bit wary, some of these pins are a little bit mullered now. Especially those on the then stick that back in. Quickly tap all that lot over. Just going to touch these two up because that one did look like it had got a bit of a dry connection underneath it. It's not going to help us though because all the resistors are all blown on it anyway. Right, I think we'll call it there. Well, that's not going to get mended, but we have mended this, so at least we've mended something. Bring it back into view again. Yeah, I was rather interested in that. I rather enjoyed that. Something a bit different for the channel. Will we keep doing it? Who knows? Let's just put my cap back on that. Actually, to be honest, I don't know why I just don't leave that permanently attached and then just hook that over there. There we go. Put that back in there, turn that off, turn the light off. Now it's working. Soldering iron off. My soldering station's shit. It matches my soldering skills. I was absolutely convinced it was that opto-isolator because it made so much sense, but obviously, and when I pulled it out and tested it, it had blown, but obviously it had blown on the receiver side, and obviously the receiver is on that track where all those resistors have blown, so it's just taken the opto-isolator out as well. We replaced the opto-isolator, but now there's no power getting through to it because all these resistors here are all blown. So I think that's it. I thought we were onto something with the with that little sort of transformer there that we'd got, but that was I thought that was showing open circuit, but it wasn't. It's giving me 1.6 ohms. 1.6 ohms on that, so it looks like it's a straight winding to winding. So I think that's some kind of a suppressor, inductor suppressor. So the mains comes in, goes around that, and inducts the same mains on the other side because it's equal numbers of windings. And then we've got this thing here, which I don't know what they are. We never did find out, but we found out that was what I thought it was, and that was a bridge rectifier, which I thought that would have made sense if the bridge rectifier is shorted out, which it was kind of showing on here that it had shorted out, but it's not now. But I could have broken that. That would have explained that being dead. But I think we have got a short somewhere. Interestingly. Yeah, that's just that same reading we were getting before. 1.6. So there is a short somewhere on here. There's got to be. But we've got that track there's good, we know that, we can see that. So the tracks are all good. Oh, that's interesting, there's a short there. There shouldn't be a short there. Oh, there'd be a short there, definitely. Why is there a short there? I wonder if I'm touching another pin. No, there's definitely no short there. No short there, but there's a short there. Oh, there's a track that comes in, that's why this track comes in and goes through there and feeds that down to there. And then feeds that through to there, so yeah, again, that. But we've got nothing across there. Let's just do the diode check on that. I wasn't going to do this, we were going to pack in. This is not achieving anything. We've got a 5.8 on that, which is good, and we should have an open circuit on that. So that diode's okay. That resistor's okay. That resistor's dead. That resistor's dead. That resistor's dead. Right, it's dead. It's dead, Jim. Let it be. Put it to sleep. Right, anyway, look. It's not viable, to be honest. I like fixing stuff, but that power supply in there, which is possibly more powerful than this one, because it's difficult to tell what rating is on this one because there's nothing to give it away. There's no markings on it. But from what I had to do to get the light to fire up, I've kind of worked out it's 12 volt, about 1.5 amps. So this what we replaced it with was a 12 volt 2 amp. So that should be better. It should be more powerful. This is a lot more complex, and I could have had one of these almost identical to this at about £8. So even at £8, this isn't viable to fix, because by the time I've bought components in boxes of 10, you know, I started recapping it and doing things like that. It's not worth it. I suspect it's that's gone, because there's nothing coming through on that side, so it's not inducting at all. So I think it's that's gone. I've thought it's several things that have gone, but I keep going back into it's that's gone. I can't be asked to desolder it to test it, so who knows. But the power supply that I put in it only cost £5.26. So for the amount of hours I've spent on it, I should have just bought the power supply, you know. But that kind of defeats the object. The whole point of this, camera's died. can't be asked to power it back up again, so we'll do a little short and we'll use it at the end of the video. Yeah, the power supply. So, power supply's dead. I think it's that. We've just spent hours on this. We've replaced the opto rectifier, the opto isolator. I've had the bridge rectifier out. I've had all sorts of stuff out. Can't find out what it is that's gone. We're just not getting voltage on the other side of this transformer, and it's a switching transformer, so either the condition's not met to power it or it's dead. I think it's dead. It's not worth me going any further with this. As I said, I spent a few hours on this. It belongs in that there. That wasn't that expensive. Can't remember how much, but I've got another one of them which has got a similar fault. I bought a slightly more powerful version of this switching power supply for £5 something or other for Amazon. It came the next day. I'm already £4 into it in parts just for the opto isolator, which we thought had gone. Then I thought the bridge rectifier might have blown and shorted, because all these resistors here are all knackered. So anyway, upshot of it is that's probably going to go into the parts bucket and see if we can steal anything off it for future projects. It's not worth me mending it. I was curious to see if I could fix it, because I'm new into this electronic shit, but hey ho, we couldn't. But there it is. I'll leave it right there. This is a short, and it's also the end of the video.